All right, so let's look at the definition of a null hypothesis. So a null hypothesis is a mathematical equation that's claiming either no significant difference between a sample statistic and a population parameter, or no significant difference between two or more statistics between two or more samples. So what I'm doing is I'm just kind of covering all my bases here. This would be something like from chapter 10, or even chapter 13. This one, the top one, is something that you would see more in chapter 9. Uh, so the null hypothesis assumes the newly obtained sample data will not deviate significantly from the population. So some non-significant variation of the sample statistic from the population parameter is expected and defined by the confidence level, like 95%. So let me see. So what do we mean here by some non-significant variation of the sample statistic from the population parameter? So when we think of maybe the example of being presented, with a box of a dozen donuts, right? So here someone's being presented with a box of a dozen donuts, and you think, okay, if you give someone a box of a dozen donuts and you say, take as many as you want, um, maybe in a sample of, 30 people, the average number of donuts that were taken was 3 out of 12. So, you would expect that even with an average number of 3, that if an individual took 4, okay, that's one more than the average, but that's not out of the ordinary. If another person took a donut and they took 2, okay, that's less than the average, but that's not out of the ordinary. But if another person just took the box and walked away and said thank you, they took all 12, that's out of the ordinary, right? What does one person, need with 12 donuts, right? They need it for something, but it's not typical. So what you're looking for is you're looking for a non-typical event, or what we call a rare event to occur. The null hypothesis is the hypothesis that nothing new is happening here. Everything is as we would expect. We're going to account for a little bit of variation, but a little bit of variation isn't going to trigger a rare event. So the null hypothesis is a statement, which means we're not expecting anything radical. We're not expecting anything new. We expect just the normal thing to keep happening. We expect the average thing to keep happening. So, how do we represent that idea mathematically? So how can no difference between the population parameter and a sample statistic be expressed as a mathematical equation? So between population mean and sample mean, we could say that the difference between the population mean and the sample mean is 0, right? So for example, if the population mean of the number of donuts that someone walks away with was 3, and in our sample of 30 people, 30 students, the sample mean was 3 donuts, then sorry, I put standard deviation there, didn't I? Bad professor. There we go. Then what's going to be the difference between those two? It's going to be 3 minus 3, which is 0, right? There's no difference between the population mean and the sample mean. So this is a mathematical way of saying that there's no difference. The difference between them is 0. Now, another way of saying the same thing is if you apply a little bit of algebra and you think of this like an algebra equation, you could add the sample mean to both sides of the equal sign. And a minus sample mean added to a positive sample mean, that would cancel out. And it means that the population mean is equal to the sample mean. That's another valid way of saying there's no difference between them because they're equal. Okay, just be prepared. This probably makes a little bit more sense, but just be prepared to see it expressed this way too. That if you take a population mean and you subtract the sample mean from it, and if it's equal to 0, that's another way of saying there's no difference between them. We can do the same thing, not just with means, but between standard deviations. We could say that the difference between the population standard deviation and the sample standard deviation is that there is no difference. Their difference is 0. Or they're equal to each other. There's no difference. We could also do the same thing with population proportions and sample proportions. We could say that the difference between them is 0, or that they're equal. And if they're equal, there's no difference. Okay, so there's there's these different ways of representing like a null hypothesis. There's no difference. All null hypotheses equations will have an equality in them. So up above here, I said that the population mean is equal to the sample mean. The population standard deviation is equal to the sample standard deviation. The population proportion is equal to the sample proportion. So when you set up null hypotheses, you're going to be saying that the null hypothesis is that the population mean is equal to some value, or the population mean is greater than or equal to some value, or the null hypothesis will be that the population mean is less than or equal to some number. So just notice that all null hypotheses will have an equality in them. So notice that, equals, that's just equality, but this greater than or equal to has an equality in it. This less than or equal to has an equals in it. Okay. And, these are some examples of null hypotheses centered around a mean, a population mean and a sample mean. We could do the same thing by creating a null hypothesis if we were talking about a hypothesis test involving standard deviations. Or if we were doing a hypothesis test around a proportion, then we'd be creating null hypotheses around proportions. So again, note that each of the 9 null hypotheses equations equates a population parameter to a sample statistic. So let's look at an example. So you can imagine maybe this top half, being a hypothesis test that you're going to conduct. Okay, and then down below is kind of how we would process this word problem, what stuff we would tease out of it, and how we would interpret it. So in 1998, as an advertising campaign, the Nabisco company announced a 1,000 chips challenge, claiming that every 18-ounce bag of their Chips Ahoy cookies contained at least 1,000 chocolate chips. Dedicated statistics students at the Air Force Academy randomly selected bags of cookies and counted the chocolate chips. So what they did is from an entire population of 18-ounce bags of chocolate chip cookies, these statistics students went out and collected a sample. So they went out and collected bags of chocolate chip cookies, opened the bags, and then started counting the number of chocolate chips uh, in each bag of cookies. So let's take this and break it down. So when we see the words like every 18-ounce bag, that is, we're going to translate that into is all 18-ounce bags. And that's our population. Population is all 18-ounce bags. Now, this part of at least 1,000, okay, that means the average number of chocolate chips is at least 1,000. Okay, so now how do we start to translate this into a mathematical equation? So we can think of the average number of chocolate chips is at least 1,000. We could say the population mean is at least 1,000. Okay. Now notice here I've gone ahead and I've substituted the symbols that we use generally to mean this and this, right? The population mean is given by this variable, mu. And when we say is at least, we usually use greater than or equal to. So how do we translate this now? Well, we kind of just eliminate the words. And now we've got mu is greater than or equal to 1,000. So we've taken, these words here and converted that into an algebraic inequality. Okay. And this algebraic inequality has an equality in it, right? Because it's greater than or equal to. And so because this is greater than or equal to, that is going to be our null hypothesis. And a critical thing you want to remember here is that this null hypothesis is our original claim. That's the claim that's being made originally in our problem. You're actually going to want to write this down next to this null hypothesis that you just wrote down. Because labeling this as your original claim, you're going to refer to this at the very end of your hypothesis test in order to make your conclusion. If you don't keep track of this at the beginning, you'll get the answer wrong at the end. So don't forget to mark down whether the null hypothesis or the alternate hypothesis is your original claim in your problem. All right. Now, for some practice and to help you visualize this, because remember I talked about the null and the alternate being binary choices. It's either the null or the alternate, right? There's no gray area. So let's look at the null hypothesis and see what that translates to on a number line. So it'll help to visualize the null. It is, after all, an inequality in one dimension. So if we draw this number line, and this number line is This is in the number of chocolate chips in an 18-ounce bag. And what we're claiming is that the amount of chocolate chips is greater than or equal to 1,000. So here we are at 1,000. And because it could be equal to 1,000, we're putting a closed dot, and it could be everything greater than that. So we could have 1,000 chocolate chips. We could have more than 1,000 chocolate chips. And because this is the null hypothesis, we're going to say it's not going to be out of the ordinary for there to be 1,000 or more chocolate chips in a bag of cookies. That's going to be normal. That's not going to be unusual. What would be unusual is that we have less than 1,000. Okay. Now that line was a little thick there. So let me do that again. So what would be unusual is if we had less than 1,000. So not including 1,000, but less than that. That's going to be our other binary choice. That'll be our alternate hypothesis. Okay, and I kind of, jumped the shark a little bit, by kind of giving you that this is going to lead to the alternate hypothesis. But this is the binary choice we've got. You can see that this choice of 1,000, exactly 1,000, is covered under our definition of the null hypothesis. So when we define the alternate hypothesis, it cannot be equal to 1,000. It's got to be strictly less than 1,000. So now we've got our two statements that are binary choices. Okay. All right, let's stop there because next we'll talk about the alternate hypothesis, and we'll go into that into some more detail. Let me know if you have any questions.